Welcome to the session. And as Madhuri mentioned, that today I'll be talking about the role of automation in energy efficiency enhancement. Right. So let me start with this image. Okay. So which looks like a water container. And if you see this water container, so water is being continuously filled into this water container. But unfortunately, this container also has some holes from which the water is escaping out. So what it means is that the amount of water that is being put into the container is going out and getting wasted, right? So somebody who want to use this water will not be able to use the same quantity of water which was put inside the container because of these wastages. Now, our energy sector or energy network is also very much similar to this container. High leakage would mean that if the leakage is high, so that means the losses are very high. Or even when we use more and more fossil fuel energy, so that would mean that cost would be high, right? So what do we do in case we have to increase our efficiency? So somehow we have to minimize the losses and also minimize the cost of energy, which is being put into the energy network. So if I have to put efficiency into formula based on cost or energy utilization, so it is always a function of output versus input. Right. So if it is cost efficiency, the amount of money you put, money you are realizing from that investment upon the money that you put to produce that energy, right? Even and regarding utilization, so are we able to use the same amount of energy which we put into the network? So this can be different, and more utilization happen, the more efficient system would be. Now, if I have to increase efficiency, what I need to do based on the formula that we have seen, that we have to maximize the output. That means we have to reduce the losses, or we have to minimize the input cost. That means we have to use more and more renewable energy resources there. So, but how do we do that? If you've just seen this transition, observe this transition from in the container, so it just, so you can see there. So if we put some mechanism which can monitor what's happening inside the grid network, okay, where the faults are happening, where the leakages are happening, where the energy wastage are happening, or where the thefts are happening. If somebody is able to monitor these losses inside the system, and then after monitoring, they're able to measure that how much actually it is happening, which is more significant, which is less significant, and then you generate a lot of data because of that. And then based on the data that you receive, you take some decisions. And based on that decision, you take some corrective actions. And every corrective action will bring some change into the efficiency. Your efficiency improves. And this is an ongoing cycle, right? So every time this never ends. So every time you monitor, you measure, take some decision, take some corrective action, and it just goes on. So this is called energy enhancement, efficiency enhancement cycle, right? And this can be done either manually or automatically as well. So manually would mean that, okay, somebody is recording the pattern in energy network. Manually they're recording the data, right, from the meters or whatever resources they have. And then they sit with the data and they take some action. So this is also a way of handling that system, right? So which will also give the result, but will that result be fast enough? Probably not. So automation is actually doing the same thing. So automation helps the users to monitor a wider in the wider aspect, right? So more precise informations can be gathered with the timestamping, and then a lot of with the data that is available, a lot of calculations can be done automatically where people don't need to spend time. And when the data is available from the automation systems, then it can suggest the corrective actions as well, or the people responsible for the taking corrective actions, they can decide what corrective actions they need for improvement of the system. And eventually, when this cycle goes on, so gradually with the time, efficiency of the system does grows, right? So this is what automation is all about, right? Putting into the energy network. So you monitor, You measure, collect the data, and take corrective actions. So that is the energy automation. It is different from the standard automation that we see in our factories, because in our factory, what we see, it's more like you have to produce something, right? So you need some inputs, then build up a process. Based on the process, you generate an output, right? More or less same, but in energy, it's more about monitoring and data and taking insights from the data to take corrective actions. So you have the generating plants at the in the top, which feed to the transmission network, maybe HV level or sub-transmission level at 130 kV or 110 kVs. Then it is after the long transmission lines, it reaches to the areas and localities where it need to be distributed. So these sub-transmission line go into the distribution substations, where it is stepped down to maybe 33 kV level or 66 kV level. And then these further distributed to the localities where people do live, where the industries are stationed, right, or where the agriculture farms are there. Okay, so this is a standard energy value chain. Okay, and but with the concept of smart grid, another thing is happening, which is called concept of DERs, distributed energy resources. Now, which the earlier the power generation, which was primarily happening at some central location, maybe in some states which are more rich in the nuclear in the fossil fuels, right? The coal, they have more coals, and the availability is there, so they're producing the power, and then the power from through the entire system was reaching to the people who need to consume that. So long distance, the electricity has to actually travel to be actually consumed. But with the smart grid, what's happening is that the distributed energy resources are being placed near in the distribution network itself. So a small, maybe 10 megawatt or 20 megawatt solar plants are coming up, or small wind farms are coming up, or even biogas or biomass generating units are coming up, and all the battery storage systems are also coming up. So all these form a small smart grid, or you can say a microgrid kind of environment. So this also helps in energy efficiency, because then the energy which is being produced locally can be utilized in the local vicinity. So the actual losses of transporting that power from a distance generating station to the consumer is actually minimized. But yeah, this is the concept which is coming up. And then we have the demand side consumers, the homes, in the industries, or localities, even the malls, commercial complexes, offices, so everything put together, they come into the demand side consumers. In all four segments: generation, transmission, distribution, and demand side, right? So like generation, they have aims to increase the renewable capacity expansion by 500 gigawatts by 2030, right? So also they are like encouraging more DRs to come up, like rooftop solar plants are coming from rooftop solar mission, that people buy solar and they put into their homes or their localities or societies, and biomass energy or battery energy storage system. So the government is promoting all these things. In the transmission side, we see, yes, they're not big transmission schemes as of now. Yeah, some projects are on, like routine projects are going on, but one big project, one big scheme is already ongoing, which is Green Energy Corridor. And this is again focused primarily towards the renewable energy, because when we say that we are going to add this much capacity of renewable energy, so this energy also is required to be connected with our national grids, right? So you need a brand new infrastructure to evacuate that power from the renewable energy and connect to the national grid. And another scheme which is primarily focused on the grid reliability is URTDSM, which measures the turbulence in the grid, which measures the transient in the grid, and that says, okay, how much is the grid reliable, what is the source of turbulence that is coming to the grid, and if grid can collapse or not. So it does automatically all those stuff. So URTDSM scheme is there. Again, this becomes very, very vital because of implementation of RE, because RE resources are not very stable. They are very intermittent. So bring a lot of transients also to the network, right? So in case of distribution segment, we see the government has this RDSS scheme, which is, I think, one key umbrella scheme, which is aimed to reduce the AT&C losses into the distribution network by average of 10 to 15%, and an average cost of supply gap of average cost of supply with average cost of realization to zero. That means at least the amount being spent to create that much energy is recovered from the consumers. So if not profit, if no profit at all, right? And for that, this has two aspects. Like one is smart metering, that you enhance the revenue collection, a better metering, efficient metering, and revenue collection from the consumers, and additionally focusing on the transmission, sorry, the technical side, which is the infrastructure strengthening. And on the demand side, so the government have initiatives like BEE coming up with standards and label for home appliances. You see that you'll find that B star ratings in your home appliance, a refrigerator, air conditioner. So it tells that, okay, this particular appliance is more efficient. It's a 5-star rated. This is 3-star rated, right? So people are encouraged to buy higher efficiency equipment so that the wastage of energy can be minimized. And for the agriculture side, so the schemes like PM Kusum are there for Kisan Urja, for farmers to make them self-reliant on the energy, so that their irrigation pumps, which are there in the plant in the farms, can run through the solar energy. And also they can have a small solar facility plant also be built up in the fields where they have some maybe barren land or something, right? So which can be utilized for their own purposes. And then energy code, efficiency code for the buildings. Like a lot of infrastructure development is already happening in India. And buildings also consume a lot of energy, and especially most of that energy consumption happens in either heating or cooling of those buildings, right? So, and of course, the lighting. So we have natural light available, and we have um, air conditioning or HVAC is running, right? So the B also actually giving the star ratings to the buildings just for making building more efficient towards the energy. And with government aiming to put a lot of EV transportation system, like they want to replace all the cars in India by 2032, 100% EVs. But that would mean that a lot of pressure would come on distribution networks for EV charging. So the government has that mission of PM E-Drive EV charging, which talks about charging more efficiently the vehicles in the peak off-peak hours and all those things. So, and if you see, the core aspect of all these schemes always have automation as integral part of the projects.